Okay, so here's what you're learning about today. This is something brand new. You guys have never seen this before. You know, there are two real special numbers that you've been taught that are so unique in math that they have letters saying what they are. So one of the numbers you know about is the number pi, right? You guys have all learned about pi. Oh, that's 3.14. Then you learn, well, it's not really 3.14. It's 3.14159266. It keeps going on forever. It never stops, right? And it's such a unique number used for so many different things that it got its own symbol, letter, pi, right? And then this year you learned about this thing, this imaginary number known as I, right? Okay, well, there's a third number you have to learn about, okay, which is called Euler's number, okay? Or some people pronounce it Euler's number, okay? It depends who you talk to, okay? Which is this little e. Okay, now this number is on your calculator. The number's on your calculator. So what you can do is this. Go to the calculator and hit second, and above the division sign is the e. So hit second divide, and you see how it pops on the screen? Then press enter, okay? Then press enter, and you will get this number right here, like it's saying. Everybody's seeing that? Okay, so 2.718281828, right? Okay, this number is irrational. It goes on forever, right? It goes on forever. Okay, so it's an irrational number, okay? Now what makes it such an incredible, great number is this, that when we get to logarithms, we're going to use this number to help us solve certain kinds of logarithmic problems. Okay? So what we're talking about today is graphing this. Okay, so here's what's going on. We want you to graph this function, right? Y equals 3e to the 0.25x. Now look also at this. There's another way to do this. You can hit seconds and then hit LM, which is on the left-hand column of your calculator. And what will pop on the screen is e to the caret, right? Everybody see? Okay, when you get, then you put the power in there, right? Okay, so we type that into the calculator. Different numbers, right? There's only going to be one nice number on that. What number is that? 30. Okay, 30, 03. You got it. It's 03 right there, okay? And then all the other numbers are like little kind of silly decimal numbers, right? Okay, so what you're going to do is then go and put these silly decimal numbers on there also and graph this, right? Okay, so sure enough, look here. Here's an asymptote right here, right? Okay, and this is asymptotic to y equals 0, or the x-axis, right? Is what you get. Okay, yeah, well, that's what they say, asymptotic. What a cool word. Okay, all right, now, let me ask you this. Now that we got this graph on there, what's the domain? Negative infinity, curvy. You got it. See, this is so simple to do. It's like, oh, I got this. And then what's the range of this? 0 infinity, curvy. You got it. See, look at there. I can do this. This is easy. Okay, not difficult to do this. Okay, everybody good so far? Okay, now, what it says up here is this. If this power is a positive number, it's going to grow, right? It's going to be a growth. So when the number is a negative number, like the second example, negative 0.75, then it's going to be what? It's going to decay, right? That's what you're about to see, okay? So everybody will type in letter B now. We'll type that into y equals, okay? All right, so the 1 is the asymptote, right? So you can draw y equals 1 right there, like that. And then here comes the graph. It should look something like this, right? Is everybody understanding what's happening? All right, now tell me this. What's the domain of this one? Infinity, curvy, right? Same thing, same song and dance. Okay, and then what's the range of this one? 1 infinity, curvy. You got it. See, it's very simple to do this. Nothing difficult. Okay, so everybody else so far what we're doing up to this point. Okay. Okay. All right. So let me ask you this first about example 2. How are you going to label the x-axis? That's the Okay, the years, right, that's gonna be years, okay, or it could be time, you can put down time or years, all right? And each square is gonna be how much? Each square will represent how much time? 1 year, exactly, each square would be 1 year, of course, that makes total sense. What's the y-axis gonna be? Y-axis? Length in centimeters, you got it, length in centimeters, right? Okay, so here's the x-axis, I'm gonna put 0, 1, 2, 3, 4, I thought that's enough to put there. Now remember the challenge, it's the y-axis is the challenge, how to scale that, right? Okay, so remind me again, now what number are you gonna put in the calculator? What number would you put in the calculator? Look at the equation. Let's say again, what's the number? Now, not 400, a little bit too much. What number are you going to put in the calculator? It's there in the formula, 337. We're going to put 337 in the calculator. What are you going to divide it by? 14 or 15, and then round it up, right, to a nice number. Tell me what you make each square. 25. You got it. It's going to be 25. You see, you got this. You understand how to do this. And you have to do that on the test. So here we go. There's 25 for each square, and then I'm going to every 4 squares, 100, 200, 300, right? And then I topped it off here. I think the 350. Okay, there's 350. Like that, okay? All right, so now we're all set to do the graph. All right. Now let me ask you this. Where's the asymptote? Y equals what? It's the asymptote. Just look at the, no, look at the equation. Y equals 1, it's the asymptote. Look at the equation. $337, right. Y is 337, it's the asymptote. You got it, exactly right. So at 337, you're going to draw an asymptote like that, right? Okay, and then you're going to push that into the calculator and start graphing it, right? Now estimate the length, right? That's 3 years. So 175, very good, is right. It's about 175 centimeters. Is right, that's the answer, okay? So the tiger shark that's 3 years old is about 175, right? Yeah, we're not to be yet. Now we're going to be. Okay, it's all right, no problem. No problem. Just gonna mix up which one we're doing. Okay, all right, now let's go to B. Now you have approximately how old is a tiger shark that is 250 centimeters in length? About 7 years. Is right. Okay, now remember, you don't know how to do this yet, right? All you can do is use this silly graph and look at the table, right? About 7 years. But now remember what you're going to get to learn how to use? After we take the test, then we start learning how to use logarithms, okay? And when you use logarithms, then you're going to find out exactly how old it is. So I did this without you knowing how to do this, right? I did this morning, right? And here's the real answer to the question. The tiger shark would be, okay, about 7 years. Right? So tiger shark would be 6 years, 175 days, 4 hours, and 48 minutes old when it gets to be that length. Okay. I will show you how to do this, but that's not until after we take the test, and I'll start teaching you how to do this. It's fascinating to learn how to do, and it's also not that difficult to do once you learn how to do all this stuff. And it's all the calculator. It's almost totally calculator with a little bit of algebra involved. Okay, but it's a lot of calculator-driven stuff. So it's like, oh my gosh, it's so simple to do this. You'll find out how later. Okay, all right.